Warahmatullahi wabarakatuh. So here is the video that I promised to you. That is a video for revision on some questions from our current midterm exam and also selected questions from quizzes for semester 2, 24 and 25. And this is mainly for Econ 1302, mathematics for economics and also business. Now, I'm not going to start from quiz number 1, but here I prefer to start from quiz number 4, because quiz number 1 until quiz number 3, some of them, majority of them I had discussed it before midterm exam. So let's look at some of the question of quiz number 4. So this is a quiz number 4 question. Question number 1, suppose that a certain product has the following demand and supply function. So these are the demand and supply function that you can see clearly. And here, question A, find the market equilibrium price and quantity demanded. And the question B, if a 15 bucks tax per item is levied on the supplier who passes it on to the consumer as a price increase, find the market equilibrium price and quantity after tax. Okay, so for question A is a very straight to the point questions. So to answer A, before you go to the calculation or the calculus, you must write the condition, because the market equilibrium condition must be there. It's not just calculus. So here equilibrium condition, is actually demand equal to supply, isn't it? Now in this case, this must be equal to this. So here we write it underneath of D equal to S. This one must be written. If we just put all the maths without putting this condition, then all the maths here are, meaningless, because we can always have some equalities for other types of functions, but they can give many different types of meanings, such as not only equilibrium condition, it could be some other conditions. Do you get me? So this term must be written before you go to the, these two terms before you go to the calculus. So here, continue with the calculus, minus 8Q plus 2,800. 800 equals to 3Q plus 35, and then you rearrange it as usual. Okay, so here is very obvious, and here in it, so I bring it to this side. So it becomes 2765 equals to 11Q. So from here you can get Q equivalent to 2765 divided by 11, and then simplify it further, and you're gonna get 251.3636. Don't leave it just like that, because when I mark your quiz last time, I can see many of you leave it just like that. You need to give the final answer. Now, question A is not finished yet, and we need to find equilibrium price as well. So how to find equilibrium price? Once you've found equilibrium quantity, which is this, okay, or this, but this one is not the final answer, this is the final answer. What you can do is that you insert equilibrium quantity that you have found into either this or this, okay? So here, now because I don't have enough space for question A, so I bring it here, but when you answer final exam, answer it in an organized way. Here I just want to save some space so that I can still refer to the question question A when I talk about the answer for question A. Okay, here, so here P equivalent to 3 times what? In the calculus, it's easier to use fraction rather than the final answer. Final answer, you leave it just like that. But to find another answer, you use the fraction for quantity. So here, 2765 over 11, and then plus 35, and then you should get something like 789, okay, 0.09 dollars. Okay, so that's for question A. Now, if we look at question B here, if a $15 tax per item is levied on the supplier, who passes it on to the consumer as a price increase. Find the market equilibrium price and quantity after tax. Okay, so to find this, what you can do is that you need to understand the concept of tax here. Then only you can do calculus. If you don't understand the concept of tax here, then when you do the calculus, you may insert this $15 into wrong equation. It is levied on supplier. I remember I did explain to you in the lecture thoroughly about this. So I just go through the calculation. So what we can do, because it is levied on supplier, because tax is the determinants of supply, not demand. So it will be added directly to the supply curve. 15 added to the supply curve. All right, so it becomes like this. Let me show you here. So, demand curve stay the same. So I rewrite again the demand curve 8 minus 8Q plus 2800. Okay, but the new supply will be this. So here we have 3Q plus 35 and then add 15. So our new S becomes 3Q plus 40 in it. Then to find the answer when the tax is imposed, so we need to find the new equilibrium. So rewrite again the new equilibrium condition is given by D equal to S prime in it. So here minus 8Q plus 2800 equals to 3Q plus 40, and then you rearrange it as usual. Here I'm not going to show you the details, but you need to show the details. And finally you're going to get Q equivalent to 552. Okay, so Q here, no, it's not equivalent to 552. It can't be, I'm sorry, because the value here is lesser. If you do the calculus, it's going to be 760 divided by 11, isn't it? So you're going to get what here, and then whatever you get here, okay, let's say whatever value here, you insert it back into either this or this to find what is the new price. So this one is the new Q, this one is the new price. That's it. So basically with this with this new tax, so if we have new tax, so basically how many quantity do we have? So we're going to have 250.9091, and then price you put inside it back here. So like I told you, you can use either this or this. Let's say I use demand here, so it's going to be, let me erase this one first. So it's going to be minus 8 multiplied by this ratio, 2760 over 11, and then plus 2800. Okay, so in this case, so we have 8 times 2760 over 11. Okay, and then so what do we have here is that plus 2800. It's gonna be very expensive. You calculate it yourself here, yeah. So but then if you see the question here, B, if I add another question like the one in the quiz originally, comment on the answer that you found in A and B, for instance. So how to comment? How to comment here is you compare between the old price and also the new price, whatever you found here. You compare between both of them, get the difference, show the difference. P prime minus P, what do you get the difference? The difference is increase or decrease? Same goes to quantity. Logically speaking, to answer this, because tax is imposed, logically speaking, quantity will reduce. But by how much? By how much is you see the difference between old quantity and the new quantity. You calculate the difference. And logically speaking, when tax is imposed, then the price will increase from P to P prime. By how much? By whatever value you get here minus the value that you get earlier for the price. That's how you answer when the question or the exercise asks you about command the answer of the difference between A and B. So that's for quiz number 4. Okay, now we move to midterm exam. Here, I would like to remind you once again, I'm not going to explain everything. Okay, some of it I may skip the step, but you have to do it because, like I told you last time, you are expected to do it. And don't wait for my answer tonight because exam is tomorrow. Here is just for you to revise again the answer whether it's correct or not. Okay, so let's look at midterm exam. I pick question number 1. Solve the following of system of equations. So if I consider this as equation 1, this as equation 2, if it says solve, it means what is the value of x, what is the value of y. That's what it means. So what you can do here from 1, now I'm going to show you how to do it. From 1 here, you can basically from 1, we can have y equivalent to 2x minus 2, isn't it? Okay, because we rearrange it for bring 2x to the right, it becomes, and then it becomes 2x minus 2y becomes positive. Okay, now we call this one as equation number 3. Now, what we need to do with equation number 3 is that substitute equation number 3 into 2, isn't it? So when we substitute, remember we need to find x and y. So here it becomes 3x plus 4 times y. We substitute y with 3, with equation 3, put it here. 2x minus 2 equal to 6. Then we expand it. 3x plus 4 times 2 becomes 8x. 4 times minus 2 becomes minus 8. Okay, equals to 6. Then you rearrange it until I'm not going to show you the detail because this is just a calculus until you get final answer x equivalent to 1 3 over 11. What I found from your answer last time is that you only stop at x equivalent to 14 over 11. This is unfinished work. You need to simplify it further until you get this. Now, once you get this, you can use the unfinished work to solve for y. And to solve for y, so use x equivalent to 14 over 11 into whichever you want, either 1 or number 2, equation 1 or equation 2. So here, if let's say I use equation 1, so 2 times 14 over 11 minus y equivalent to 2, isn't it? And then you solve it, show all the details. You're going to get y equivalent to 6 over 11. Okay. Now, let's move to the second question. This is also solving, simultaneous equation. To solve this simultaneous equation, I'm not going to go into detail because actually, like I told you many times in the lecture, this is one of many examples of exercises that you have done in the high school. So let's say this one is expression 1, this one is expression 2, equation 1, equation 2. Okay, what we can do with equation 1, as you can see here, we have fractions. So fraction makes our calculation a bit more difficult in this case for the first step. Okay, so what we can do, we try to omit the fraction. The fraction for both of them here are 4, so it's a bit easier to omit that fraction. How do we omit it? It's like, multiply expression 1 by 4. Okay, so when you multiply expression 1 by 4, then you have something like this: 4 multiplied by 10 over 4 and minus 4 multiplied by 14 over 4 times n, isn't it? minus 1 multiplied by 4, isn't it? So when you simplify it, then you get 10m minus 14n equals to minus 4. So we call this equation 3. So now we can work with equation 2 and equation 3. So you do it on your own until you get m, okay, should be equivalent to 1 and n equivalent to 1. Try to get until you try to do the calculus until you get m equivalent to 1 and also n equivalent to 1. Okay, now let's move to the next question of the midterm exam, which is question number 3. Okay, I pick question number 3 here. A bakery shop incurs cost for a cake given by Cx equivalent to 70x plus 2300, and the revenue function for the cupboard is given by Rx equivalent to 170x, where x represents the numbers of cakes. Calculate the following. A. How many cakes must be sold to obtain break-even? B. What is the total revenue and total cost at break-even quantity of cakes? C. If the seller wants to target profit level of 2700, how many units of the cakes must be sold? Okay, so let's look at question number A here. Question number A is talking about break-even. Break-even is a condition, is a kind of condition in which revenue equivalent to cost. So how do you answer this question? Before you go into the calculus, you must write down the condition. Break-even condition is what? Okay, revenue equals to cost, because it uses this symbol, so that's why I use this symbol also. You must write this, otherwise whatever you write here is meaningless. Okay, so break-even condition, R equal to C. R equal to C is what? It's a break-even condition. So here 170x equal to what is it, 70x plus 2300, and then you rearrange it, okay, and show all the step until you get x equivalent to 23. So that is the quantity that can give you break even. Okay, now we move to question number B. What is the total revenue and total cost at break-even quantity of cakes? So this is quantity of cakes that gives you break-even. Now you need to calculate what is the revenue, what is the cost. Sorry, let me erase it first. What is the revenue at the break-even? Or in other words, what is the revenue when 23 cakes is sold? And then what is the revenue and what is the cost when 23 cake is sold? That's the question. So you need to calculate these two. So you must have these two answer. So for the first one, it's very simple. So what we can do is that we take the revenue function, which is 170x. We substitute x with 23. Then you get the answer. What is it? So same goes to cost function. Cost function, you have 70x. So x here, put 23 instead and plus 2300. Okay, what is the answer? Because this question is about break-even, so you should expect the answer for revenue must be the same as the answer for cost, isn't it? Because this is the condition. So in this case, you should get 3910, 3910. So that's for B. Okay, right. Now, and for C, if the seller wants a target profit level of 2700, how many units of the cake must be sold? So profit. Now the question is about profit. But the equation given to you are only cost and also revenue. So you need to find profit function or profit equation. So profit, let's call profit as P. This is question C. Is basically revenue minus cost, isn't it? Okay, and it says that if I want to get profit equivalent to 2700, Okay, how many x I should produce and a sale. Okay, so this is the question here. So what we can do, so we have written the profit function. This is how it looks like. Now we need to insert the revenue function here, so it becomes 170x. We also need to insert cost function. Look at this carefully. I put square bracket and then I write cost function as usual, and then I close the bracket. And this what I want to have here. Let me erase the line here. What I want to have here is that this must be this, isn't it? So this is very straight to the point. So how to solve it? 170x minus, when you want to open the bracket, 70x. After opening the bracket, the plus here meets minus becomes minus, and 2300. So you rearrange. I'm not going to show you the detail here. And you should find the answer equivalent to 50. Okay. All right. So that's for question number 3. I'm not going to discuss other types of question for midterm exam, and I would like to remind you, like I told you in the class, that matrix chapter is not included in the exam. Matrix chapter. When I say matrix chapter, you don't be confused with Hessian matrix, bordered Hessian matrix, determinants for optimization and whatnot. Those things for optimization is in different chapter. This is matrix chapter. Matrix chapter will not be included in the final exam, but matrix for optimization in chapter of optimization, multivariate and whatnot should be included, should be revised for your exam purpose. Okay, all right. Now let's crack on. We move to quiz number 5 now. Okay, so here for quiz number 5, I choose this question. Find the derivatives of the following. So fy equals to 5y squared plus 6y. So find the derivative means it wants you to find the answer for differentiation. So question A, how do you write it? F prime y equals to 5y squared. 5 is a constant, y squared here is the, you can use power rule, 5 times 2y, and then 6y becomes 6, okay, 10y plus 6, that's it, okay. All right. Now, what about B? I found that many students made mistake in question number B because they don't know which one is the variable, which one is the constant. Here, Fm, that means the equation here depends on M. So, variable is M. Other alphabets are not variable, they are considered constant. So, in this function, you can see W. This function does not depend on W. How do you know? You look at this. This function depends on M. Therefore, M is the variable. W is just a constant like 5 and 2 and also 1. Do you get me? So here, if I want to find derivative of this, which is f prime m, so because I consider 5 as constant, so 5 stay because 5 multiplied by m and the rest. I also consider the denominator over 2w plus 1 as constant, so I rewrite it again because the whole constant here is multiplied by m. So when I differentiated m here, m 1 minus 1, isn't it? So it becomes 0, isn't it? So m to the power of 0. Okay, m to the power of 0. That means what? That means it's equivalent to 1. Do you get me? So the answer is 5 over 2w plus 1. That's it. Very easy. As long as you know which one is variable, which one is constant. That's it. Okay. Now, apart from question from quiz number 5, I do have some additional question here, which is this. Additional question for exercise. Derivative for this, yeah. So let's say we have this. You can see here y as a function of x, in which in square bracket x plus 2 multiplied by x to the power of 4 minus 5, and then close the bracket, the whole thing to the power of 3 or cube. Okay, or basically cube. Okay, so how do we find derivative here? To find derivative, first we write the derivative sign. It can be either this or this. Either one of these can be the derivative sign, but you have to show this sign before you show the answer. Okay, now what rule we can use here? The whole thing here, if you recognize, the whole thing is in square bracket being powered by 3. The whole thing in square bracket cube. You get what I mean here? So when it is like this, and inside this, the whole bracket, square bracket here, you can see variable. Here, variable x, here, variable x. Okay? So in this case, it's very obvious that you should use chain rule to differentiate. Chain rule. So how to differentiate this? Look at this carefully. Power, I bring it here, becomes, the base, constant. And then I rewrite again the whole thing in the bracket as usual. Can you see? And then close the bracket, but the power here becomes 3 minus 1. Okay, it's unfinished work because we haven't differentiated the one inside the square bracket. As you can see, the one inside the square bracket, I put it some part here, x plus 2 in bracket times x to the power 4 minus 5. So this multiply by this. Okay, because it's multiplication, when you do differentiation, you can use product rule. Okay, you differentiate this first, this stay constant, and then plus, differentiate the second one, this stay constant. Okay, so here I continue, yeah? So I continue, because like I told you, this is unfinished work. So here, it becomes, okay, see carefully. I want to differentiate x plus 2 first. X, when I differentiate, it becomes 1. 2, when I differentiate, it becomes 0, isn't it? But this one stay constant, isn't it? X to the power 4 minus 5. Okay? And then plus. Why plus? Because I'm using product rule. This multiplied by this one stay constant. X plus 2 stay constant, but this one we need to differentiate this. X plus 2 stay constant, but this one we need to differentiate. So how we differentiate it? 4x cubed, isn't it? Minus 0 because no x here, so when you differentiate it becomes 0. And then close the bracket. Okay? Now, second line, 3 x plus 2 x to the power 4 minus 5. This becomes square, isn't it? Now, this one becomes 1 plus 0, 1. 1 times the whole thing here becomes x to the power 4 minus 5 plus stay plus. This one, x plus 2. This one, 4x cubed minus 0 becomes 4x cubed. Okay, that's it. Done. Okay, so this is how it is answered. Okay, this is additional bit apart from the exercise from the quiz. Okay. All right. So quiz 5 are done. But we still have question number 2 for quiz number 5. Suppose that the total revenue function for a commodity is R equivalent to 36x minus 0.01 x squared. Sorry, yeah, this one should be square. Let me change it to square. Okay, so find revenue when quantity x is 100 and tell what it represents. So for question number A, this is how we're going to do it. It's very simple actually. A, revenue of 100 is equivalent to, you take the revenue function here. So 36, insert 100 minus 0.01 x squared. So you change the x here to 100. Okay, multiply by 100 square. Then you calculate what's the answer. Okay, so the answer should be 3,500. Okay, so this one shows the sales. Revenue actually shows the sale from the commodity of 100 units. That's how you answer tell what it represents. Okay, so it shows that the sales of 100 units of commodity is 3,500. Okay, now B, find the marginal revenue function. Marginal revenue function is actually the differentiation of revenue function or total revenue function. So how do we do it? Delta R over delta X. So we differentiate revenue function with respect to X. So 36X here becomes 36. Okay. Minus 0.01 x squared here becomes 0.01 times 2 x to the power of 1, isn't it? So it becomes 36 minus 0.02 x. So that's your marginal revenue. Okay, question number C. Find the marginal revenue at x equivalent to 100 and tell what it predicts. So what you can do is you have found the marginal revenue function. You substitute x equivalent to 100 back into this new marginal revenue function. So marginal revenue of 100 equal to 36 minus 0.02 times 100. And what is it? What is the answer? Okay, so here you put the answer here. Okay, the answer here would be 34, isn't it? Okay, but then the second part of the question tell what it predicts. It tells that the next additional sales will give you 34 marginal revenue or $34 of marginal revenue. Okay, additional 34. Okay, now but the second part of the question, the next 3 units, the additional next 3 units, if one additional unit gives you 34 revenue, the next 3 units, so the next 3 units, then we can have 34 times, okay, 3, it gives you 102. This 102 is the additional revenue of the next 3 units after 100 unit being sold. That's how you explain the meaning. Okay, and then D, find the revenue of 101 quantity and also 100 quantity. 100, explain what this value represents. So this is no longer marginal revenue. This is revenue, like the first question here. So you see revenue 100, revenue 101. Find the difference. Revenue 100 we have found, which is 3,500. So you need to find revenue of 101 quantity, then you get the difference. So first get the revenue for 101 quantity. So 36 times 101 minus 0.01 times 101 to the power of 2. What you're gonna get here is basically 3533.99 something, and then only from here you can get, the difference between revenue of 101 minus revenue of 100, which is equivalent to 3533.99 something minus 3500, which is 33.99. You can see here, this one is almost the same as 34, isn't it? So it explains what? The next additional quantity, if we sell, it gives us additional revenue of 33.99. That one is what we call marginal revenue. So this is what it represents, marginal revenue of 100 unit of commodity. Okay, so we are basically done with that one. So quiz number 5 is done. I'm not going to discuss quiz number 6 here, sorry. Quiz number 6. Now we go straight to quiz number 7. Quiz number 7 here, Arding Private Limited produces t-shirts and sells X t-shirts per month. The monthly cost and demand equations are given by C and also P. P is not profit function here. P here is demand function. See carefully. In which that quantity must be between 0 up to 5,000, the limit. Okay, A, calculate the production level that maximizes adding profit. Maximizes adding profit. Okay, you have cost, you have demand. But the question is asking about production or quantity, how many X that can maximize profit. That's the question. So the first thing here is that you need to know, in order to answer A, you need to know the formula for profit. Profit, I use different symbol P, equivalent to what? Revenue minus cost. But here cost is given but not revenue. So how to find revenue? Revenue is simple, price times quantity, isn't it? Price is given here. So you just need to find price times quantity. In this case, quantity is not Q, quantity is X. Price times X. So here we can have revenue function. Price, we have 100 minus X over 20 multiplied by quantity X. So here P times quantity minus cost. Be careful, look at what I do. Cost 2500 plus 50x close bracket. Okay, so when we simplify, profit function become 100x minus x squared over 20 minus this, okay, minus 50x, isn't it? This, if we further simplify, it becomes 50x minus x squared over 20 minus 2500. But this is not answering the question. This is just the first step of answering the question. We found the profit function, then we need to maximize the profit function, then only we can find quantity. So now, how to answer question A for the remainder? How to maximize profit? To maximize profit, we need to do differentiation and find first order condition. Maximize profit, I'm still in A. First order condition is given by differentiate profit function with respect to quantity X. So what do we get here? 50x becomes 50 minus x squared over 20 becomes 2x over 20, isn't it? Minus 2500 becomes 0, then equal to 0. Why do we need to equal to 0? Because it's about maximization. First order condition, when we maximize, this one is at the top. When it is at the top, your slope at the top is 0. This one is actually slope. Delta P over delta X is actually slope. I mean, that's why we need to write first order condition and equate it to 0. So here, maximize profit must be written. First order condition must be written and then equate it to 0. And then we solve it. So from here, we can solve for x. So 50 equals to 2x over 20. In fact, we can simplify it further. It becomes 10, isn't it? Then you have x equivalent to 50 times 10 equal to 500. So this is the quantity that maximizes profit. So we have answered question A. I put answer for question B here. Yeah. What is the price that adding private limited should charge to maximize its profit? So we have maximized profit using this. We have found quantity. We only need to find price. So how to find price? Put the max quantity that maximize profit, which is x equivalent to 500, back into price function. This one is price function. Price function is a demand function. Is it clear? Okay, so to answer B here, so we write P equal to 100 minus x over 20, isn't it? So we replace it, 100 minus 500 over 20. So what's the answer here? So when you simplify, the answer is 75. That's it. That's for B. And then finally, what is the maximum profit? Okay, the maximum profit, you have profit function here. So I put question C here, yeah, because I don't need that. I just want to put everything in one, page or slide so that you can see the question and also the answer at the same time. But here, I move from A to A here, B here, and then C here. But in the exam, you cannot do this, yeah. All right. Now, so profit, we have profit function with this, which is this. What we can do is, we insert the quantity to find what is the profit that has been maximized. Quantity that maximized profit is this, isn't it? Okay, so here profit equivalent to 50 times 500 minus 500 square over 20 minus 2500. Then you get the answer. So you should get the answer equivalent to 10,000. That's it. Okay. All right. So I hope this is clear. Okay. Question of this quiz. So this is the demand for fried noodle in Taman Melati is given by P equivalent to 40 times E to the power of minus 0.01 Q, where Q packs of fried noodle are sold per day at a price of P each. Calculate the packs and price that will maximize revenue from the sales of fried noodles in this neighborhood. Okay, so if you see here, price that will maximize the revenue. What we are given is demand. Demand is actually price, not revenue. So in order to maximize revenue, the first thing is to find revenue function. We know that revenue function is actually price times quantity. So here we have price, which is 40 E minus 0.01 Q, and then we multiply by Q. Okay, so that gives us revenue function, which is 40 E minus 0.01 Q times Q. Okay, to maximize revenue, we need to know how many Q and what is the price. That's the question. How to maximize revenue? That means we need to get the first order condition for revenue function. What we need to do is write this down, maximize revenue, FOC, because FOC means revenue at maximum point. So differentiate revenue with respect to quantity. How do we do it? You see carefully here. This is 40, this is constant. If you see this, we have what here? We have this multiplied by this. These terms multiply by this term. When it is multiplied, we can use product rule. Okay, product rule. How to do product rule here? So 40 stay the same. I'll do this way. Okay, I'll differentiate this first. This one, leave it just like that, isn't it? When I differentiate Q, it becomes 1. E to the power of minus 0.01 Q stay the same. Because I'm using product rule, now I add plus sign. Plus sign, and then I differentiate this E with and Q constant. So Q stay the same, but I need to differentiate E. Now, how do I need to differentiate E? What I can do, rewrite again E to the power of minus 0.01 Q, and then differentiate this with respect to Q. So when we differentiate it with respect to Q, you see here, multiply by minus 0.01 Q becomes 0.01 minus sign. Q gone because Q becomes 1, isn't it? Okay, and then close the bracket. Equates it to 0. Why? Because it is FOC, revenue at maximum point. So this is actually marginal revenue at maximum point. Okay, which is 0, slope is 0. Now what we can do is we can simplify it further. Can you see here? 40 you bring to the right becomes 0, isn't it? So we can simply erase 40. Sorry, yeah. Or I can just simply dash 40. So we are left with the one in the square bracket. What we can do, we can still factorize it because we have common factors. What is the common factors here? It is this. Can you see? Okay. When you see this common factor, you factorize it. It becomes E to the power minus 0.01 Q, and then inside becomes 1 plus minus 0.01 Q, isn't it? Equal to 0. So E bring to the right here becomes 0. Okay. Then I can simply cancel E. I delete this so that you are not confused. Then I'm left with 1 minus 0.01 Q equal to 0. And then from here, I can have 1 equal to 0.01 Q. Q equivalent to what? Then you can cross multiply. Okay. Actually, this one is equivalent to Q over 100, isn't it? So you can cross multiply 1 times 100 equal to 100. So quantity here is 100. But we haven't answered the question price here. How do we find price? So here, for price, you just need to substitute it back into the price function or demand function, 100. Then calculate, what do you get? That's the answer. Is it clear? All right. Now, we move to next quiz, which is quiz number 8. This is about mixed partial derivative. Okay, mixed partial derivative. Okay, so here, let product A and product B are related and their demand functions are given by these functions. Okay, A and B competitive or complementary goods. Justify your answer. Let the unit prices of A and B are 0.5 and 1.5 respectively. Calculate the change in demand for A. How will your answer in part B change when the price of B is increased and new price is 2.5 while the price of A is constant? Okay, now let's do question A. Question A, how to check whether A and B are competitive or complementary? What we can do here, because we have two equations. Equation 1, we differentiate QA with respect to price of B and then get what the answer. Question 2, we differentiate QB with respect to delta PA and get what's the answer. From this answer, you see the sign whether it's positive or negative. Then you can decide whether it's competitive or complementary. Let's look at A. Quantity A. Delta QA over delta PB. This one becomes 0, isn't it? Because there is no PB. This one becomes 0, isn't it? When we differentiate. Now, this one becomes what? It becomes minus 600 because constant. Okay. Then this one is actually equivalent to this. Minus 600 times PB plus 1 to the power of minus 1, isn't it? It can also be rewritten as this way. So when I differentiate, it becomes minus 600. The power here, bring it here, minus 1. And then PB plus 1 in bracket to the power of minus 2. This is, chain rule. I can simply write 6 over PB over plus 1 equal to 600 times PB plus 1 to the power of minus 1. Then I can do differentiation as usual. So here is going to give me minus makes minus positive 600 PB plus 1 square, isn't it? Which is positive. Now, let's look at delta QB over delta PA. What do I get? Okay, if I differentiate this with respect to PA, it becomes 0 because I don't see PA. This one, yes, it exists PA. I know that I can rewrite it as minus 400 times PA plus 4 to the power of minus 1. So if I differentiate it, it becomes what? Minus 400 times minus 1 PA plus 4 to the power of minus 2, isn't it? So then this one, when I differentiate, because there is no PA, the whole thing becomes 0 after differentiation. So here, final answer is minus minus becomes positive 400 over PA plus 1 square, also positive. When the answer is positive for both of them, then we know that it's competitive. Competitive. Why? Because for the first one here, when PB increases, QA increases. The second one here, when PA increases, QB increases. That means when price of B is relatively expensive, people buy more of A to substitute B. Same goes to price of A. If price of A is more expensive now, people buy lesser A, people buy more B to change because A is more expensive. So they are competitive. Okay, now let me erase the mess first. So next, B, let the unit price of A and B are 0.5 or 50 cent and 1.5. Calculate the change in demand for A. So here, the change in demand for A is this one. D means, or delta means change, QA means quantity of A, demand for A. Not the change in price of B, not the change in quantity of B. It is asking you about A. So we only look at the first differentiation that we have done. So we know that delta QA over delta PB is given by 600 over PB plus 1 square, isn't it? It says that let unit price of A and B are 0.5 and 1.5. What should we do? Calculate the change in demand for A. Calculate the change in demand for A due to price of B is 600 over PB. PB is what? 1.5 plus 1 and then square. And then you calculate what happens here. Where is PA? PA is not in the answer, so you don't have to insert 0.5. Okay? And then, how will your answer in part B here, in this one, change when price of B is increased and new price is 250 instead of 150? So this one, I use red pen. You just need to change it to answer C. Okay, you just need to change it. Delta QA over delta PB equals to 600 over the new PB, which is 2.5 plus 1 square. And then you calculate. Once you calculate, because it wants you to answer the difference, you compare this answer with this answer, see the difference, find the difference, calculate the difference. Calculate the difference and show that the difference is this much, whether it has increased or decreased. That's it. Okay? So that's how you answer this. Bonus question. This bonus question, I'm not going to be very detailed, but I expect you to do the detailed work. Yeah. Here I just guide you and just give you some idea about how to answer the question and the right, types of graph. But the details of it you must provide. Here a factory manufactures cakes and bread, each requiring the use of 3 operations: ingredient preparation, mixing, and baking. The first operation can be used at most 44 hours, the second at most 50 hours, and the third at most 27 hours. A cake requires 1 hour of preparation, 2 hours of mixing, and 1 hour of baking. A bread needs 2 hours of preparation, 1 hour of mixing, and 1 hour of baking. The profit is 20 ringgit per unit for a cake and 30 for a bread. Let C be the number of cakes made and B be the number of bread made here. Okay, so here, what is the objective function of this problem? The objective is to maximize profit. How do you know? The profit is 20 for cake and 30 for bread. Okay, so the objective function should be written as this. Let's say profit is P. P equals to, profit per unit for cake is 20 C cake plus 30 B. What I found from the exam last time when I marked this bonus is that you use X and Y. Please follow the instruction. Don't use your own, alphabet when there is instruction given in the question. Okay? Otherwise, we cannot give you mark. And actually, it's wrong, totally wrong, because if a person is Ali and should be characterized as A, and you characterize him as Z, what is that? Do you get me? Okay? So this is objective function. What are the inequality constraints based on the operational limit? Operational limit here, if you look at the question carefully, you have preparation, mixing, and baking. And you have cake and bread. Okay? Preparation at most, 44. Mixing at most 50. And the third one, the third baking here at most 27. But both of these has cake and bread. Cake and bread. Cake and bread. So how to write the inequality constraint? For preparation, a cake requires 1 hour of preparation. For preparation, a bread need 2 hours of preparation. So here, the first constraint, I write it here for question B. The first constraint here is that 1 cake and 2 bread less than 44 hours or equal to 44 hours. Okay, for mixing, a cake requires 2 hours of mixing. Bread requires 1 hour of mixing. So the second one here is 2 cake plus 1 bread. 1 bread just B less than what? Or equal to 50. The third one is what? Baking. 27 maximum. For cake 1 hour. For bread also 1 hour. So here, cake and bread, that's 27. What else is the constraint? You have to make sure that cake and bread, each of them must be 0 or positive. You can't produce negative cakes, yeah, or negative bread. That's it. Okay? Now, so that's answer the constraint. Draw a graph and show all the feasible region for the problem and clearly label the constraint lines and feasible region. Now, I would show you how to draw each of the line because this one has been shown in the lecture. I just show you the finished graph, but in the exam you cannot just show the graph. You need to show how to draw each of the line. Yeah. So here I just jump into the steps, few steps not shown. You remember C and B. Okay. So I consider B here. I consider C here. Okay, so my B is according to your understanding is Y. My C is according to your understanding is X. Horizontal axis. Okay, so now I just show you all the graph. So the first graph that I'm showing here is this graph. Okay, this graph, the name is 2x plus Y equal to 50. Okay, and then here is 0, 50. Here is 25, 0. How to find 0, 50? How to find 25, 0? How do you know that it is straight line? How do you know that it's downsloping? Make sure you know the basic of drawing graph. Show the slope. Show the shape of the graph. Calculation of first derivative, second derivative. Vertical intercept, horizontal intercept must be shown for each of the line. For each of the constraint. That's what I mean. Okay, next. I have this line. Okay. This line is actually, let me erase this, is actually x plus 2y equal to 44 on this line, okay, all right, and then here is 0, 22, and here is 44, 0, okay, and then the third line is this. Be careful. You look at the way I draw because I found that many students got this wrong. Okay, it must be below this. The drawing is not perfect, but I just want to show you this. So this one is actually x plus y equals to 27. The question, if you go, but before that, let me rewrite the intercept here. This one is 0, 27. This one, yeah. This one is actually 27. Not clear. 27, 0. That's it. So the question asks you, graph, show feasible region, and clearly label the constraint lines and feasible region. But before you can show all of that, you should show me how to get each of the line. How do you know it's downsloping? You know the basic drawing of line. How to get the vertical axis, the calculation, everything. Okay, now the feasible region here. Okay, you look carefully. Okay, let me use different color. Let's say red. We need to determine the corner point. This this, this, and this. Those are the corner points. So the corner points here is 10, 17. The corner points here is 23, 4. The corner point here is 25, 0. This one is 0, 0. Do we need to find corner point here? No need, because this is not considered as the boundary. So where's the feasible region? You have to check, yeah? I'm just giving you the final answer. You have to check how to know this. Okay, here, 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 here. That's it. So this, label it feasible region. Okay. But all of these points, you need to show how to get it. How to get this, how to get this. This one, you don't have to. This point, you don't have to, because it's not included as the boundary of feasible region. Need to find how to show, 10, 17, 23, 4. This one, of course, you show it after you calculate the horizontal axis. This one, yes. This one, yes. Okay, and then finally, determine all corner points of the feasible region and label them in the graph. I have labeled them in the graph, but I just need to list down all of them. First, 0, 0. Second was what? Second was, if you look at the graph drawn here, 0, 22, 10, 17, 23, 4, and 25, 0. So here, 0, 0, 0, 22, 10, 17, and then 23, 4, and then 25, 0. And then lastly, how many cakes and bread should be produced to maximize profit? How many cakes and bread that should be produced to maximize profit? You have all those points, corner points, you have 5. What you need to do is to calculate revenue, profit function, using profit function 5 times. So you have this profit function, calculate for 0, 0. This is C, this is B, isn't it? So you have for 0, 0. So your profit is what? 20 times 0 plus 30 times 0, 0, isn't it? You have 0, 22. Profit becomes what? 20 times 0 plus 22 times 0. Plus 22 times 30, sorry. Plus 22 times 30, isn't it? And then you get what? And then you do for this, you do for this, you do for this. Find the maximum answer. That maximum answer, you must write down. Maximum profit is what? Choose. So quantity for C is what to maximize profit, B is what to maximize profit. Don't just tick like that for the maximum profit. Okay, you answer it properly. Maximum profit is what? After you choose out of 5. C is what? B is what to maximize profit. Write another sentence here. Don't just tick your answer. This is maximum. No, it's not like that. Is it clear? All right, now. So this is the end of the revision of the quiz, selected quiz, and also bonus question, and also midterm. But don't just depend on this. Don't forget all the exercises that I have discussed in the classroom, yeah? And also I didn't discuss to you bonus one. I didn't discuss with you Hessian and whatnot, because I did discuss to you in the class, so that's why I don't put in the video. So those things, take it seriously as well. Hessian, determinants, metric, test, optimization and whatnot, multivariate, maximization and whatnot. Also partial derivative, higher order derivative, those things that I have discussed in the class, including the exercises. So all the best for your final exam, and try your luck, try your best, inshallah. Okay, thank you very much. Assalam.